Well, my friends, I'm here at Jimtoff and very excited to talk about additive manufacturing. It's one of my favorite subjects because, well, we think it's the future, we think it's the now. Some people have been doing it for a while, so it might even be the past. But we had these grand ideas of what it might be, taking over the industry. No more removing a material anymore. It was only going to be additive. Well, we're taking a step back now. We're realizing that that broad, expansive mindset might need to be fine-tuned a little bit, and maybe even in some places, a niche that can help you make a lot of money. I got Simon here with me today. We're here with Matsuura, and we're going to talk about a lot of these ideas, where it can help you, and at the end, we're actually going to show you something you have probably never seen before. So Simon, let's start with the overview of additive manufacturing from the Matsuura perspective, but also from the global perspective of what it was originally anticipated to be.
Well, for me, Tony, the hype around additive manufacturing, I mean, it's crazy. It's going to take over the world. Everybody thinks they can press one button and build anything you want to build. Yeah. In reality, we know there's a lot of difficulty in producing a good part from an additive machine. And with this business in general, you can be sold an additive machine, and then you're basically being asked to become an expert in order to run that machine. And it's not feasible from a business point of view, it's not feasible from a manufacturer point of view in able to sell these machines. And that's what we're all about.
Simon, I am totally with you. I've been into so many shops where the additive machines are just sitting there like lumps, not being used. And you're right, it's like going back to the old days of machining where they said, here's your machine, figure it out. Well, now here's your AM machine, figure it out. And we think that we're experts because somebody did it one time, because GE did it, because SpaceX is doing it. We think we can all do it, this creative, broad mind. And I think we need to be more specific and more educational in how this can actually benefit someone. And if I'm going to bring that up, and I'm going to think about Matsuura, and I've had this conversation with Yuto previously, so I have a little bit of gift to know about this machine. Isn't this a hybrid machine and not just an additive machine?
Exactly.
Where does hybrid come into play?
Right. So, yeah, we talk about additive manufacturing. Matsuura, obviously, they have the blue machines. These are all subtractive milling machines. This is a combination, a hybrid of both additive and subtractive processes. So, yes, we're building up the material, solidifying a laser, building up in layers, same as your usual powder bed process. But what we have here is actually a machine with a machine spindle as well, so we can do both processes on one machine, hence the hybrid additive LUMEX machine.
Well, I want to talk about that a little bit more, but while we do, I want to invite the audience to come take a look inside this machine. Simon, could you describe a little bit more about what's going on inside of there?
Yeah, so basically at the moment we're on the machining process. So we've already built up this part layer by layer, like I said before, like a standard powder bed laser additive machine. And with the spindle, this allows us to go in and to machine those surfaces as the part is being made. And really, Tony, this is the key to this process overall, is that we are not making an additive part and then taking it somewhere else and post-processing it. We are doing the machining process during the actual build. And this is something that allows you to access areas of the part that you cannot access afterwards once it's built.
Yeah, very well explained. And as we discuss this a bit further, Simon, there are these grandiose ideas about what we can do, right? There's a grandiose ideas about the potentials of what additive manufacturing can do. But if we think about what's actually happened and the expansion of taking over, we haven't quite made it, and we might. And I know Matsuura's entire point of the original machines of metal removal, if you build it, they will come kind of a thing. Right. So you've realized, as the whole world is taken on additive, that maybe, just maybe, there's these niche areas like Matsuura was brilliant enough to do with their pallet machines to say, we can help you thrive, we can help you succeed. Is this true for these hybrid machines that you're talking about right now?
Tony, definitely. I mean, what we're looking at here is how do we get to a perfect part or a usable part as quickly as possible with the least effort possible from, or the least know-how, if you like, from the user side. We all know the fanciful perceptions of GE, LEAP engine, this type of thing, but this takes decades of experience to actually produce. And there's plenty of users of the additive machines now that are suffering with this. What we're aiming to do with the Matsuura machine and the Matsuura process is to provide basically a CAN cycle. You take your design, you put it in the CAM system, it makes the program, and it produces the part. The know-how and everything is kept within the process, and that's what we offer to our customers.
Simon, I myself am a very much show me kind of person. I mean, that's my personality. You and I can talk all day. We can invite the audience to look inside the machine. We got these beautiful parts right here, but you have an area that I think is fascinating just over there. And because your booth is busy, we might have to move some folks out of the way, but let's go take a look. As we walk in this general direction, my friends, I keep bringing up to Simon about the idea of something niche. And if our camera guy can kind of point in this general direction, you see parts that are, as I've used the word grandiose, really complex and creative, right? And I think it's important to understand that if you can do that, then by all means do that. If you have the education to be an AEM type of person, then do it, right? However, we are now standing in front of an area when we speak about Matsuura being the go-to company for hybrid, and the niche of die and mold, or mold and die. This is the world that you guys are currently thriving in, and we want to educate them on, right?
Right. Yeah. Well said. Basically, I mean, we are interested in the here and now. Yeah, the potential for additive, I think we all can see, and yes, we will eventually get there, that's for sure. We are interested in the here and now, interested in my business, interested in the customer's business. Where can we apply this technology here and now and get real life usable benefits?
Do you know anything about the song Jesus Jones? Right
no,
here,
but I
right
think
now.
You're going to tell me.
Well, we are in Japan, so sometimes I try to do karaoke, but I'm going to save the audience today. Plus, Yuto Matsuura is right here, and he's shaking his head like this. Don't do it, Tony. But I will bring the camera in. Come take a look at this. Simon, you told me a story about something about 85 different pieces. If we were going to traditionally machine this, would be the components to make this piece. This is done in one setup.
Exactly. So the conventional method of making this mold would have been in 85 different pieces. Each of those pieces require the sync EDM machining. You need an operator, you need the machines, you need the programming for all of this. What we do here on the LUMEX hybrid technology is create basically the part as you see it there in one process directly off the machine.
Simon, I'm looking at this and my mind is blown in many of these areas, and I'll tell you why. And if we could zoom in here, actually, I want to show you just how cool. I mean, this is a functional piece right now, but as I'm looking around, Simon, I'm going to play the role of someone that's not an expert like you. And I'm going to make the assumption there might be a couple of folks out there that aren't experts like myself, and I love being in that role with you. I would say this looks like it's additive. I would say this looks like it's additive, but maybe complicated. I would say if we can come a little bit closer and look at some parts like this, I mean, the holes are tiny in there. And when I look at this piece and when I look at this piece, they look like extremely high precision machine removal parts, but these are all additive hybrid machines, aren't they?
Exactly. And I think if most of our audience would probably understand the benefits of the additive technology, what we think about is conformal cooling channels, freeform surfaces, and this type of thing. And primarily this has always been the benefits that have been applied to the mold tool or the die industry. But what we have here with the hybrid is because you can combine more of the molds into one single piece, you can take advantage of the additive benefits with the conformal cooling, and also what you see here, the porous, which you could not use before until the hybrid process was available.
All right, Simon, we're gonna bring this whole thing back full circle again, because we've already discussed the fact that additive machines have been thrown into shops and pretty much given a thumbs up and say, good luck guys, you can do it, you're an expert now, right? It happens all the time. But I have to bring up that from your perspective, and I'm looking at some tools right here, that this is actually a lot less complicated than someone might think, isn't it?
Exactly. I mean, we've talked in depth about the hybrid process, which includes the milling machining, and some people will probably think this is way beyond what I want to get into with an additive machine. But basically, any of the parts that you see here that are produced with the hybrid process would only basically use these 5 tools.
Well, we got to show the 5 tools. Please explain when we say these 5, what I can do anything I want with these parts on these 5 tools. Well, how is that actually true?
Basically, when you build these parts with this process, you're building each of these parts layer by layer. So from a process point of view, each layer is exactly the same. You're making a 2D scan path for the laser, and you're making a 2D path for the machining. And this is all done within the CAM system, and layer by layer, you will create the 3D form that you want. So whether I make this, whether I make that, the process is exactly the same. If the user has their CAM model, the design of the mold, drop it into the CAM system, let the CAM system do its magic, creates the program, set up the machine, and let it run. And this is what you get at the end of the process out of the machine.
All right, Simon, well, we're gonna close this thing out, but before we do, I have another question, and this question was unplanned, unscripted, although most of our conversations are unscripted. I'm just a very curious person, and I get to talk to experts like Simon, hopefully bringing that information to you as I knock things off the table. So, when you describe the tooling, when you describe the process, when you describe the ease of use and the multifunctional additive and subtractive, I really feel like I'm saving a lot of time and a lot of resources and a lot of money. Am I correct in that thinking?
Absolutely correct. But it's the application of the additive process for a process that works now. So, okay, there's a lot of talk in the industry about design for additive and this kind of thing, and this is where you need, in a way, you need the software to catch up with the process that is available. What we're looking at here is a process that's already developed specific for this niche, which to us is the mold and tool, and with that single process, you are applying it to more and more molds, whereby you're saving time in the manufacture, cost in the manufacture, you're saving labor skill sets, you don't have different types of machinery to support, and then you are getting the benefits of the additive manufacturing itself when you come to mold the part. So you've got conformal cooling, you've got porous gas ejection, you've got less warpage in your part, and you've got a faster cycle time. This is where the magic really happens, brings it all together to an application that works here and now.
All right, Simon, one final statement as we close this out. A lot of folks have been burnt on what something can do for someone, the idea. We keep saying here and now. How do we turn naysayers into believers? Is it just give me a call and I'll prove it to you? How can we turn all these folks to say, nah, this is just a sales pitch, that's not gonna work. There's truth in this right now. How do we turn those naysayers into believers?
Well, absolutely, it is prove it and it is show me. There's a lot of talk, but what we are here and presenting now to the market is basically come to us, let us show you. not explain it to you. Let us show you. Let us make a part. Let you take that part, use it in your own process, evaluate it yourself, and then I don't think there's any further explanation needed.
No, once people start seeing time savings, money savings, everything that's involved in making that a reality, perspectives change. It is that easy. If you want to try this out, give my friends over at Matsuura a buzz. If you're a naysayer right now, there's a reason why we are talking about it, so that it can prove it to you. So give them a call, see what they can do for you. It just might change your entire process inside your machine shop. This is hybrid manufacturing. This is my buddy Simon, and this is Matsuura.